Hey, this is chapter 39, Quality Integrated Manufacturing Systems. As you see, you're only responsible from the first three subsections. You're not responsible from the rest. They are quite detailed topics. So I'm going to just discuss the first three topics. So in the previous chapter, actually, we discussed some things about quality integrated manufacturing systems, and in such systems, we prefer to have some group technologies employed so that productivity will be improved, and in shorter times with less cost, we can manufacture products. And you will see some examples of these applications. The first one is cellular manufacturing, in which we have a cell, a kind of a room. We have seen an example in the production of Apple Mac Pro. If you remember, there was a cell, and at the center of that cell, we have seen a robot, and robot was responsible for carrying items from one unit to other unit, or carrying the items and putting them onto the conveyor belt. So it's some kind of an example of a cellular manufacturing, but flexible manufacturing systems are a bit different. These are much larger systems compared to the cellular manufacturing systems. So let's briefly go through cellular manufacturing. As I mentioned, it's a bit smaller than the flexible manufacturing systems. It's a unit consisting of at least one or more workstations. And if it has a one machine, then it's called a single machine cell, or it has several machines, then we name it as a group machine cell. And the machines in this cell can be modified, retooled, and regrouped. So this is highly important. The machines should be quite flexible. Otherwise, we cannot name this one as a cellular manufacturing, since it will be a dedicated system and you can only produce a single product. But if the machines can be modified, retooled, and regrouped, then that means you can change the resulting product. And with the help of these modifications, you can produce parts within the same family. So we are kind of applying a group technology approach in this one, so that similar products will easily be manufactured. And in cellular manufacturing, sometimes we may have robots, or if it's a manned version, manned machining cell, then we should have workers around, and they will be responsible for carrying the items from one station to the other station. But for dangerous environments, for, let's say, toxic environments, it's better we use an industrial robot at the center, so that it will be responsible for these tasks. And we have flexible manufacturing cells. It's highly similar to the cellular manufacturing. It's a part of or an example of an cellular manufacturing. And this ones, we prefer to make use of computer numerical control machines. So they are much more flexible. So by installing some different programs, scripts, they can produce different products. And again, it can be automated with the help of robots or some other mechanized handling systems like conveyor belts or other transfer mechanisms. Another important issue here is that cellular manufacturing and flexible manufacturing can be utilized after forming the families by using the group technology approach we discussed in the previous chapters. So if you don't have groups, family of parts in your factory, in your plant, then you cannot use flexible manufacturing. This is a kind of a requirement to use flexible manufacturing approach. And the flexibility obviously has some limitation. The flexibility is always among the members of the family. If you have a totally different product, then you cannot produce it within the same manufacturing cell. You need to establish a new cell or modify your design so that you can easily fit this new design into the available families. And as I mentioned, we may have robots or workers around. Once you don't have any workers, then it's called as an unmanned version. And the accuracy is much better, obviously, in these flexible manufacturing cells. The robots are responsible for picking, placing, and other simpler tasks. And you can increase the efficiency of your flexible manufacturing cell with the help of robots. Here you see an example, and this one is an manned flexible manufacturing cell. We have several stations, as you see here. This is the whole sketch is a manufacturing cell. It's usually U-shaped or circular. As you see, we have sewing system, lathes, turning machines, milling machines, and this is for transferring the parts. We have milling machines. We have inspection stations, and at each station, as you see, we have some responsible workers. So that's why it's a manned version, but in the unmanned version or unattended version, we will have a robot at the center, and that will be responsible for such tasks, which are transferring the part from lathes to the milling machines, or transferring them from vertical milling machines to the grinder. But as mentioned many times in the robot systems, these tasks are completed by the robots. In the manned version, we may have many workers or just a single worker, depending on the complexity of your operations. Then we have a larger manufacturing system. This is called as flexible manufacturing system. And in this one, we try to make it as automated as possible. And this is not a single actually cell. It's composed of several cells, and the actually parts between these cells are transferred with the help of the robots. Again, automated guided vehicles, not just an industrial robot, but an automated guided vehicle is utilized in such systems to transfer parts from one manufacturing cell to the other one. And this is the main difference between the previous one. The previous one was, as we were discussing, a single manufacturing cell. It was, again, flexible, but this time we are talking about a huge system, and still is flexible. The flexibility is obtained with the help of automated material handling systems and robots moving around, moving between the manufacturing cells. And with the help of these extra equipment, we can produce several families, not just a single family. We can produce various products in different families, since we have many manufacturing cells, and that means we have more flexibility. And here you see an example. For instance, we have one station here, another one here. So the flexibility is, that's why, much higher. And we have such automated guided vehicles. This is an example of it. And these vehicles are responsible for carrying parts from one station to the other station. And sometimes you may have extra workers beside the machining centers, but it's not a must. If there are some robots, then it can fully be automated. And here's an image of that, and a real plant, as you see. And another thing we can say about the flexible manufacturing systems is that it's actually a very nice manufacturing system, since it combines the advantages of two different manufacturing systems. The first one is transfer lines, and the second one is job shop production. If you remember, in the job shop production, we have high flexibility, but the productivity, efficiency were lower. But in the transfer lines, we have lower flexibility, but the productivity is higher. So if you combine the advantages of these two manufacturing systems, then that will be awesome. That's why some companies are preferring to use flexible manufacturing systems. This is a nice table, actually, summarizing some important properties of flexible manufacturing with respect to transfer lines. Let's have a look at them. Part variety. Obviously, we know that in the transfer lines, we have a dedicated line, dedicated manufacturing system, dedicated hardware, so we cannot change the product. But if you look at flexible manufacturing systems, we have infinite part variety, which means that you can produce any product. Since we have many manufacturing cells, we have guided vehicles all around moving, so that's why we have high flexibility. But the thing about productivity is, as you see, we have some problems with flexible manufacturing systems. The number is not high. It's a bit higher than job shop production systems, but not as low as job shop production systems, a bit higher than that. And obviously in transfer lines, our lot size or product size are usually higher. Let's have a look at part changing time. It means producing a new part. So we know that it's quite long in transfer lines, since you need to change software, write new scripts, change hardware, but in the flexible manufacturing systems, it's quite easier. You can simply write scripts, new scripts, but you don't need to change hardware. And again, this one is very similar, tool change. In transfer lines, we don't have such automated systems for tool changing, but in flexible manufacturing systems, since we are mostly using CNC type of machines, tool changes mostly automated. Adaptive control, again, is quite difficult. Transfer lines are with huge systems. It's quite difficult to control the whole plant. But in flexible manufacturing systems, we make use of computers all around by writing appropriate scripts, by employing appropriate control strategies. We can employ adaptive control. What about inventory? If you want to produce a new part again, you need to invent, you need to modify lots of things. But in flexible manufacturing systems, you don't need to spend too much time for the new products. By doing little modifications, you can produce new products and you don't need to invent any new approaches, kind of things. And that's considered the last two, production during breakdown. In transfer line, since we have a continuous line, we don't have any breakdowns. It's a continuous manufacturing process. But in the flexible manufacturing systems, we may have some breakdowns between transferring the parts from one station to the other, but it's not a big problem. We have partial breakdown, but not a big issue. Justification for capital expenditure in transfer lines is quite simple. So you can simply justify that the investment, the money you are spending on this transfer line is justified, since you will say that in a year you are producing 1 million of this product. But for the flexible manufacturing system, it's quite difficult. You may need to wait some years and produce various parts and later show that, yes, that was a good investment, but it's quite difficult to show this at the beginning of your investment. And I think we discussed all of these, or let's go through them once again. In flexible manufacturing system, we have these advantages. We can produce parts in any order. We can produce, let's say, first pens and then tablets later, so it doesn't matter. The number is not a big problem, and we have lower cost for these different products. And we discussed these. Direct labor inventories are reduced. Sometimes we don't have these issues. Lead times required for product changes are shorter, yes, since we have high flexibility. Some of the tool changing, other operations are fully automated, so with less time, we can switch to a different product. And the system is self-correcting, yes, production is more reliable, and we have uniform products at the end of this operation. But on the other hand, we have some disadvantages. There are two of them noted here. Equipment costs are higher, yes, it's somehow similar to job shop systems, since we have general purpose machinery. That's why the costs are higher, and we need to have more computer integration, and we should have workers, engineers having high knowledge on computers. And as you see here in the last thing about disadvantage, flexible manufacturing systems are not suitable, not actually suggested for low number of productions or high number of production. It's mostly suitable for medium size production. And that's all for this chapter, since the rest is not within our scope. Thanks for watching and see you in class.